are going to study piecewise continuous function. We already studied the continuous function. Now we are studying piecewise continuous function. So a function fx defined on interval ab is said to be piecewise continuous if f is continuous of ab except some finite number of points where f has some kind of discontinuity. यानी हम इसे ग्राफ के फॉर्म में समझें तो जो हमारा फंक्शन fx है वो कोई इंटरवल a to b में डिफाइंड है. ये हमने लिया है कि फंक्शन fx इज डिफाइंड ऑन इंटरवल ab. तो लेट द फंक्शन इज डिफाइंड ऑन इंटरवल ab. दिस इज आवर ओरिजिन, दिस इज द पॉइंट a, this is the point b. Now if we say y equals to f of x, f of x has this is x1, this is x2, this is x3 and so on. These are the points where let this f is this, this is this, this is this. Here what is happening? Our function is continuous. Our function is continuous on this interval a to b except some points which are the points x1, x2 and x3. Here what is happening? Here our right hand limit and left hand limit both are exist. In this interval x1, x2, left hand limit and right hand limit exist. Here right hand limit, left and right hand limit exist. Here left and right hand limit exist, but they are not equal. They are different. They are different. A to x1, the value of at a is this and at x1 is this. But when we take interval x1 and x2 partition of the interval, so the value of point x1 is again different from the value of this point. So at the point x1, our function fx has two values. So fx has discontinuity at the point x1. Similarly, fx has discontinuity at the point x2, and fx has discontinuity at the point x3. So if our function defined on an interval ab has some jump kind of discontinuity, this is called jump kind of discontinuity, and finite numbers. If it has infinite number, then function is discontinuous. But it should be finite number, some finite number of points where f has jump kind of discontinuity. Then we say our function fx is piecewise continuous on the interval a and b. So इसके लिए हम let us take some example to see it very clear. That fx is defined as f of x equals to 0 when x has the value 1 is less than pi by 2. Fx equals to sin x when pi by 2 is less than x is less than pi, and this has 1 when the value as pi is less than x is less than equals to 2 pi. Here the function has 2 points of discontinuity. Which are the 2 points? Pi by 2 and pi, because here the function at the point pi by 2 function has the value 0, and at the point pi by 2 function has the value sin of pi by 2. Similarly, at the point of function pi, sin has another value, and at the point of this pi, sin has another value. So these 2 points, this pi by 2 and this is and this is, so on these 2 points our function fx has discontinuous. So we say our function fx is piecewise continuous on the interval 0 say 2 pi. Our function fx is piecewise discontinuous on the interval 0 say 2 pi. This is clear? Now we come to function of exponential order. Function of, we can write it like function of exponential order. That's alpha. Function of exponential order alpha. So it is a function fx is defined on interval AB is piecewise continuous So we have studied the piecewise continuous function because it is use of our. So if function fx is defined on AB is piecewise continuous on interval AB is piecewise continuous on AB. हमारा जो फंक्शन है वो AB पे डिफाइंड है और वो piecewise continuous है AB में. It is not continuous, it is piecewise continuous on AB, then f is said to be of exponential order alpha as x tends to infinity if limit x tends to infinity e raised to the power minus alpha x f of x equals to 0 or finite number of. It's a finite number. If our define as alpha if limit x tends to infinity e raised to the power minus alpha x f x equals to 0 है या फिर इसकी जो लिमिट है वो सब फाइनाइट नंबर है. So it is clear if a function is exponential of order alpha, then multiplying a function by e raised to the power minus alpha x and taking limit x tends to infinity, the limit should be 0 or a finite number. Then we say our function fx is of exponential order of alpha. In other words, we can say function fx is exponential order of alpha as x tends to infinity if mod of f of x is less than some m into e raised to the power alpha x for all points x is greater than equals to 0. We also can write it in the form, but this is the main definition of this exponential order of the function. Now we take some example to clear it very. Now let f of x equals to e raised to the power sx sine of 2x e raised to the power sx sine of 2x. Now what is the order of the function fx? What is the exponential order of the function fx? So we can take the mod of the function f which is equals to mod of e raised to the power s of x sine of 2x. We know the value of the sine x sine 2x lies between the minus 1 to 1. If we take mod of this value, it is 1. We can say it is less than equal to e raised to the power x. Small function fx is of exponential order s. Function x exponential order is s. Clear? Now we have studied the Laplace transformation of a function fx. Now we will study the existence condition for the Laplace transformation. हमने ये तो पढ़ा कि लाप्लास ट्रांसफॉर्मेशन को कैसे फाइंड करते हैं, कैसे हम उसके फॉर्मूलाज डेराइव करते हैं, लेकिन हम उसकी एग्जिस्टेंस कंडीशन है उसको भी याद रखेंगे। उसका प्रूफ हमारे सिलेबस में नहीं है, बस हम उसे फर्दर स्टडी के लिए हम उसको जान लेते हैं। एग्जिस्टेंस कंडीशन फॉर लाप्लास ट्रांसफॉर्मेशन। एग्जिस्टेंस कंडीशन ऑफ लाप्लास ट्रांसफॉर्मेशन क्या कहती है कि यदि ये सिचुएशन फुलफिल होगी तभी लाप्लास ट्रांसफॉर्मेशन एग्जिस्ट करेगा, अदरवाइज इट विल नॉट एग्जिस्ट। तो इट इज द थ्योरम इज दिस, इफ आवर f is piecewise continuous, if our function fx is piecewise continuous in every finite interval let 0 is less than x is less than some point x0, and f is of exponential order alpha as x is greater than x0, x should be greater than x0, yeah, or either we can say x tends to infinity, such that Laplace transformation of f of xt exists when p should be greater than this alpha. If our function f is piecewise continuous and function have exponential order is alpha, then the Laplace transformation of function fx, which is p, which we denoted it is by denoted by f of p, exists only when p is greater than alpha. p की जो वैल्यू है वो अल्फा से ग्रेटर होनी चाहिए। अगर ये इस कंडीशन को अपना लाप्लास ट्रांसफॉर्मेशन फुलफिल करता है तो बोलेंगे लाप्लास ट्रांसफॉर्मेशन एग्जिस्ट, अदरवाइज इट्स नॉट। अब हम पढ़ेंगे लाप्लास ट्रांसफॉर्मेशन ऑफ ए डेरिवेटिव। लाप्लास ट्रांसफॉर्मेशन ऑफ ए डेरिवेटिव के लिए आवर फंक्शन fx, जो हमारा फंक्शन fx है उसे कंटिन्यूअस होना चाहिए। fx इज कंटिन्यूअस on interval 0 is less than x is less than equal to n. f is of exponential order f has exponential order alpha, and third condition is f dash x, derivative of f is piecewise continuous or interval 0 is less than x is less than n. Then if we say Laplace transformation of f of x is defined by f of p, if we say Laplace transformation of function fx is defined by f of p, then Laplace transformation of derivative of the function fx at this x equals to p of f of p minus f of 0. क्लियर? लाप्लास ट्रांसफॉर्मेशन, अगर किसी फंक्शन का लाप्लास ट्रांसफॉर्मेशन को हम कैपिटल एफ पी से डिनोट करते हैं तो उसका डेरिवेटिव का लाप्लास ट्रांसफॉर्मेशन इज डिफाइंड एज p इंटू लाप्लास ट्रांसफॉर्मेशन ऑफ द फंक्शन माइनस वैल्यू ऑफ फंक्शन एट द पॉइंट 0। हम इसे प्रूफ करेंगे। तो हम एक Laplace transformation of function f dash x. Using the basic definition of the Laplace transformation, ये क्या हो जाएगा 0 से infinity e raised to the power minus px f dash x dx. This is f dash x. Now integrating it by using by parts. So first of all, we will integrate this and write this. This will become f of x e raised to the power minus px 0 से infinity minus integration differentiating this e raised to the power minus e raised to the power minus p is outside. This become f of x dx 0 से infinity. Now limit x tends to infinity e raised to the power minus px f of x minus putting x equals to 0, this become 0 and this become f of 0 minus minus plus p 0 से infinity e raised to the power minus px f of x dx. Now in our assumption we have take that the function f(x) is of exponential order alpha, so this become 0. It is the Laplace transform of the function like this. So using the exponential of order alpha where p is greater than alpha, so this must be 0. So it is p 0 से infinity e raised to the power minus px f of x dx minus f of 0. This is what? This is our 0 से infinity e raised to the power minus px f of x dx. This is our Laplace transformation of function f(x). So it can be written as p f of p minus f of 0. This is we have to prove. Now let's take example. Find the Laplace transformation of cos of ax. Simply we know that the Laplace transformation of cos function is what? P over p square plus a square. Now we have to prove, we have to find it by using derivative formula. We have to solve it using derivative formula. उससे पहले हम एक चीज और करते हैं. We have find a Laplace transformation f of x. Now if we have double derivative of the function f of xp, double derivative of the function f double dash xp, तो what should it? ये क्या हो जाएगा हमारा p square f of p minus p f of 0 minus f dash 0. You can find it by using same previous method. Similarly we can write it in generalized form f of nx. अगर हम n टाइम डेरिवेटिव ऑफ द फंक्शन f(x) का लाप्लास ट्रांसफॉर्मेशन फाइंड करते हैं तो इट इज p n f of p minus p n minus 1 f of 0 minus p n minus 2 f dash 0 on minus f of n minus 1 0. ये इसका जनरलाइज फॉर्म है. ये फॉर्मूलाज हमें हमेशा याद रखने हैं क्योंकि इनका हम बार बार यूज करेंगे. तो दिस फॉर्मूला मस्ट बी रिमेंबर. नाउ वी जस्ट कम टू आवर एग्जांपल. नाउ वी हैव टू फाइंड द Laplace transformation of the function cos af using derivative formula. तो how can you apply a derivative formula? देखो, what is our function f of x? If we are to say that we have to use the derivative formula, then there must be the derivative. Here the function must be derivative. If you find the first derivative of f dash x, so what is this? Minus of a sin of ax. If you find second derivative, which is what? Minus of a square cos of x, cos x का डेरिवेटिव क्या होता है माइनस ऑफ साइन एक्स, तो विच इज माइनस ए बेस एन ऑफ एक्स. अगेन वी फाइंड द सेकंड डेरिवेटिव f डबल डैश x विच इज माइनस ऑफ a स्क्वायर cos of ax. तो we can write it that cos of ax equals to f double dash x माइनस ऑफ a स्क्वायर. हम इसे ऐसे डेरिवेटिव में चेंज करने के लिए हम इसे इस फॉर्म में लिख सकते हैं cos of x equals to minus f double dash x over a square. It can be written as Laplace transformation of minus of f double dash x over a square p. We know that Laplace transformation is linear, तो minus 1 over a square को हम s कर देते हैं. Now what is the Laplace transformation of double derivative of the function? We have write this is p square f of p minus p f of 0 minus f dash 0. Now which is minus 1 upon a square p square f of p. What is our function? भैया हमारा फंक्शन क्या है cos of x. We have changed our function f double dash x p of f of p minus p f of 0 into f dash 0. Now which is our Laplace transformation of double derivative of cos of ax. So what is this? This is p over p square plus a square minus p f of 0. F function is cos of ax which is 1 minus this is f dash 0. F dash 0 is sin 0 is 0. This is 1 upon minus 1 upon a square into p square into p over p square plus a square minus p. Minus 1 over a square. This is pq minus p square plus a square. Pq minus pa square over p square plus a square. p cube से p cube cancel. Minus 1 this a square this is cancel which is p over p square plus a square. We know that the Laplace transformation of cos of ax is p over p square plus a square, but we find it by using the derivative formula. So for the question, if in exam you are to say that use the question using derivative formula, then you have to solve it using the derivative formula. If it is not mentioned, then it is not mentioned, then you go to your simple basic formulas and solve. This is how we use the derivative formulas to solve the Laplace transformations. Now we will study Laplace transformation of integral. Laplace transformation of integral. We have to find the Laplace transformation of 0 to x f of u du p is defined by f of p over p. यानी कोई फंक्शन है, हमने इसको since we have taken the limit 0 to x, we can say it f of u du p, changing the only parameters. It is f of p over p. Now we will prove it. Let g of x equals to our function 0 to x f of u du. Now the derivative of the g dash x, what is it? It is f of x. If we differentiate this, we will get f of x, and what is the value of g of 0? If we put here 0, then x should be 0. So what is the value of g of 0 is 0. Now we have studied the formula of the derivative. So now finding the Laplace transformation of g dash x p, which is what? P of g dash x is our basically f of p, which is f of p minus g of 0. We can say it as p of g of p minus f of 0. g dash x का अगर हम Laplace transformation फाइंड कर रहे हैं using the derivative formula, तो Laplace transformation of a derivative of the function is defined by p of f of p minus f of 0. So here p of g of p minus g of 0. Here g of 0 is what our 0. So it is p of g of p, which is equals to L of g dash x p. Now what is our g? G of p. Our function g is what? 0 to x f of u du. So we can say it. We can write it as p Laplace transformation of function gx, which is function g what is 0 to x f of u du p, which is equals to Laplace transformation of g dash x. Our g dash x is what? F of x. Laplace transformation of f of x p, which is, we know that Laplace transformation of function f x is what? F of p. So from this we can say that Laplace transformation of 0 से x f of u du p is equals to f of p over this p is here p. It's very simple. आज के लिए हम इतना ही पढ़ेंगे, बाकी नेक्स्ट क्लास में पढ़ेंगे.